Last lecture was about learning formulas. Today we are going to stop using formulas because Cambridge doesn't ask you if you can calculate a midpoint between A and B. Instead, it asks you if you can use the midpoint to discover something that isn't written or given, right? So let's say that A is a coordinate -5 comma -15, B is 10 comma k, and C is 6 comma minus k, let's say. Now these are 3 points, one unknown, no obvious formula. Where do you even start? If questions like this make you freeze, today's lecture is going to change that. Now I would so let's say that the examiner has given you that these 3 points A, B, and C, they are collinear. Right now, what does collinear mean? That they all lie on a same straight line. Okay. Now, what must be true in such a case? So, what we are saying is that there is a straight line. A lies here, B lies here. Now their positions may be in any form. I'm just plotting it in any case. Now, what must it show you? It must show you that the gradient of AB is equal to the gradient of AC and must also be equal to the gradient of BC, right? Now, in order to find the unknown K, what you can do is you can calculate the gradient between A and B and compare it with the gradient of B and C, or compare it between the gradients of A and C. You could do anything, right? Now let's say I try to do gradient of AB is equal to gradient of AC. Let's do that and see what the value of K shows out to be. Now AB, now what is the formula for gradient? So that's y2 minus y1. Between A and B, let me treat this as y2. So this is minus 15 minus k, y2 minus y1 upon x2. X2 is going to be the corresponding value, that is minus 5. So x2 minus x1. Now this is equal to gradient between A and C. So this point and this point, again I'm taking this as x2 and y2. Sorry, what happened here? Okay, so I'm taking the same as x2 y2. So this has got to be x1 and y1, then y1. So y2 minus y1 therefore is going to be minus 15 plus k, because minus minus k is plus k. So this is going to be k minus 15, y2 minus y1 upon x2 minus x1. So minus 5 minus 6. Okay, now what does this give us? So this gives us minus times 15 plus k equals to k minus 15 over negative 11 and over negative 15. Now what I can do is I can cancel the negative with negative here. So this and I can multiply this negative 11 here. Let's cross multiply. So this becomes negative 11 times 15 plus k is equal to 15 times k minus 15. So what does this give us? This gives us negative 165. Negative 11k is equal to 15k minus 225. Now 225 take away 165 is equal to 26k. Now so 35 25 is 60. So 60 upon 26 is 30 upon 13 is going to be the value of k. So simple. So if you just thought that you had a k already, then you were wrong, because the examiner thinks that when it tells you that you have one line, therefore the gradient of AB must equal to the gradient of BC, or should be equal to the gradient of AC. Now that should be your first thought, not which formula must I apply here, but what must be true in such a case if the 3 points are collinear. So this is the mindset shift that I am going to enable in today's lecture. So let's move on to the section 2, where we are going to find the unknown coordinates. Okay, now let's say that you have a known midpoint. There are 2 points A and B, and you have a known midpoint. Okay, let's say the midpoint of A and B, midpoint of A and B is known. Okay, and and one of the endpoint is also known. Let's say that this is 2 comma 5, this is 5 comma 8, but this is not known. Let's say this is A comma B, but you do know for certain that this M coordinate is the midpoint between A and B. Now what should you do? Since you do understand that M is the midpoint of A and B, and you know the formula for this, so you can really see that this 5 right here must be the average of this 2 and this a. So I will write down that 2 plus a upon 2 must be equal to 5. Therefore, a is going to be 8. Right? Very simple. Similarly, this 8 right here, let me highlight it. This 8 right here must be the average of this b and 5. So what am I going to do? I'm going to take the average of b and 5, which is b plus 5 upon 2, and equate it to the midpoint y coordinate, which is 8. So this is going to be, b is going to be 11. So simple. So a and b is going to be equal to 8 comma 11, and that's it. So you just had to simply rearrange. The midpoint is literally averaging two coordinates. That's it. So if you know the average and one number, the second number isn't difficult. You're simply reversing an average. Okay. Now, let's say you have a line. Now I'm not getting into the process of teaching you guys the gradient and midpoint formulas all over again, because we have already done that in our last lesson on Monday, which was on coordinate geometry 1. Okay, so we are now progressing into doing our second not on Monday but on Sunday, sorry. So now we are just applying, we are doing the applicative form of those now. So if you have a, let's say that is minus 8 comma 11, and you have b, which is minus 1 comma 21, right? Now if you, sorry, let's say that you do not know, you do not have the x coordinate for b, but you do know the gradient between a and b. Let's say the gradient is 0 point or 1.5, right? Or I can rewrite it as 3 upon 2. Now your brain must whisper to you that since you're given the gradient for this line and there is one unknown, so you can apply the gradient formula between a and b, right? So which is y2 minus y1 over x2 minus x1, and which is already given as 3 upon 2. So this is nothing but 10 over k plus 8 equals to 3 upon 2. Multiply both the sides by 2 upon 3. So you get 2 upon 3, or rather you get 20 is equal to 3k plus 24. Very simple. So minus 4 over 3 is going to be k, right? That's it. Nothing fancy here. So if you have the gradient unknown and you had to find the missing coordinate, that then you could just simply do that. Now, what if you did not even have this? What if this was also unknown? Let's say this was L, but then for you to be able to find L, you should have been given what? Because now this is L, so this is going to be L minus 11, right? So you will find k in terms of L, right? So you will not have a minus 4 upon 3, but you will have a function of L for k, right? So you ought to have another equation, and now you must find that out. So let's say in such a case, Cambridge is going to give you the distance between a and b, right? So then you have to apply the formula x2 minus x1 whole square plus y2 minus y1 whole square and under root it, and then apply that. So whatever you found here in terms of L, you are going to plug that in here in the value of y2, which was L. So you will, which is going to be in terms of k, and then you are going to find that out. Okay, so this is how you use the information from the previous lesson in order to calculate the missing parameters or missing coordinates. I'm going to do a proper exam style question and show you how you can put that knowledge to use. Okay, now let's make this slightly harder. Let's say that you're given that 5 comma 7 is the midpoint of two coordinates a and b, right? And you're asked to find the value of k or give a reasonable argument against it. Now before calculating it, what stays constant, right? The midpoint formula that was x1 plus x2 upon 2, the average of these two coordinates k and 8, and y1 plus y2 upon 2, the average of these two coordinates 4 and 2k, right? So now we let us substitute directly. So x1 plus x2, k plus 8 upon 2 gives us 5. This means that k is going to be equal to 2, and let's change color for y. The average of 4 and 2k must give us 7. So this is 2 plus k is equal to 7. So k must be 5. Now since the answers for k are inconsistent, what does this tell us? It tells us there is no value of k that satisfies both coordinates simultaneously. And Cambridge occasionally constructs questions like this to test whether you're checking both coordinates instead of stopping after the first equation only, right? So my tip here is going to be that don't celebrate after solving the x coordinate. A point has two coordinates, right? Cambridge expects both to agree, this one as well as this one. Okay, so they must unanimously agree. So if they don't, the given information is either inconsistent or you have made an algebra error. Okay, so far we have been asked to find gradients. This one is going to be about the gradients or the slopes of the lines. Okay, Cambridge isn't interested in that anymore for you to calculate the gradients given 2 points. That's like baby stuff. Instead, it gives you a relationship and asks you to discover the unknown. That's a completely different way of thinking. Let's say you are given 3 points. A is 7,4, B is 19,8, and C is k, 2k, right? And they're such that AB is parallel to BC. Now make sure that you do not confuse it with the previous example in which the points were collinear. So you could do that m of AB, the gradient of AB was same as gradient of AC and was same as gradient of BC. Now AB and BC means but. Okay, so if so these points ought to be collinear. Why? Because if this is A comma B and if this is B comma C and they are collinear, so either C is going to be here or C is going to be on this side of it, either here or here, right? So A B will be parallel to BC will be parallel to AC. So that's true in this case as well. Okay. However, if you were given something like another coordinate D 1,5, I don't know, and it said that AB was parallel to DC, then you would strictly take these coordinates to find to calculate the gradient of DC and to use these 2 points in order to calculate the gradient of AB. However, that's not the case here, so we'll forget about it. So now let's try to solve it. So if AB is parallel to BC, so let us just put it here. So M of AB is same as M of BC. So M of AB is going to be 8 minus 4 over 19 minus 7, and M of BC is going to be 8 minus 2k over 19 minus k. Pretty simple. So this is 4 times 19 minus k is going to be 76 minus 4k. And 19 minus 7 is going to be 12. So this is going to be 12 times 8 is 96. 12 times 2 is 24k. So this is going to be 20k is equal to 96 minus 76 is just 20. So k is going to be 1. So the missing coordinate is C is 1, 2, and that's it. Okay. So this probably is going to be on this side of B, right? So B is somewhere here. C is somewhere here. 1, 2, A was 7, 4, and B was 19, 8, right? So the 3 points are collinear as well. Okay. Now, when you were given this information, you didn't have to start writing the formulas right away. Instead, ask yourself that before you calculate anything, what does parallel actually mean, right? So it must tell you that the lines have the same gradients, or the relationships between AB and BC, they have the same gradients, right? So M of AB was equal to M of BC, which turned out that K was equal to 1. Now the mathematics wasn't difficult, recognizing the relationship maybe was, right? Now parallel means whenever you are given parallel or whenever you see these lines, it means that the gradients are the same, right? It means equal gradients. Make sure that you are taking all these notes in your notebook. Now, so it does not ask you to find the gradient. Rather, it says that you must identify the relationship first and then you apply the formula in the second place, right? Now, if it said that the lines were perpendicular, right? Now, let me make another example here. Let's say that you have a coordinate A, which is 4, -1. You have another one, let's say B, which has an unknown x coordinate k and y coordinate s7. Now if it says that it is perpendicular to the line, I'm saying that the line AB is perpendicular to the line y equals to 2x plus 5, or rather I would say that minus 7y is equal to 2x plus 5. Okay, or I would say 7y plus 2x is equal to 5 is parallel to this. Now, first of is perpendicular to this. Now, if you have to find out the gradient of k, what you must do is you must find the gradient of this line. Now, some of the students will wrongly identify that the gradient of this particular line, let's call it L1, is going to be equal to positive 2 because that's the coefficient of x, but that's wrong. You need to take the coefficient of x once y is isolated and is the only variable on the left side with no coefficient, which means that you have to isolate the y. So y is going to be equal to negative 2 upon 7x plus 5 upon 7. Now the coefficient of x is going to be the gradient of this system, or of this line. Okay, now this is going to be equal to, now they're saying that this line has a gradient of negative 2 upon 7, but AB is perpendicular to this, therefore the concept of negative reciprocal, so you are going to do minus 1 upon this gradient, which is negative 2 upon 7, must give you 7 upon 2. So the gradient of A upon B has got to be 7 upon 2. Now you form the relationship. The gradient of AB is going to be 7 minus minus 1, that is 8, over k minus 4, and this must equal 7 upon 2, which is the negative reciprocal of the gradient of the line, right? So this is 7 upon 2. Now you cross multiply, so this becomes 16 is equal to 7k minus 28. Now 28 plus 16 is going to be 44 upon 7 is going to be equal to k, and that's it. Okay, now before calculating, you had to find the gradient of the given line, and then if your line was perpendicular, what must your gradient of AB be equal to? It should be equal to the negative reciprocal of the given line, because the two are perpendicular, right? And thereby you will be able to find the missing x coordinate of B, which was k, right? Now the important part, most students memorize this, but if the two lines are perpendicular, then the product of their gradients must produce an output of negative 1, and that's a given. You are not going to get into the derivation of this in your course, but this is always the case, right? Now I could give you the geometric derivation of it, right? I could draw the x-axis, I would draw a line, and then I'm going to put the angle theta, and then I would equate the tan of theta with m, because m is what? It is rise over run, right? Which is nothing but the ratio of tangent, right? Now, but you are not going to get into that, right? So because it includes the compound angle as well, so let's not get there. Okay, now so look carefully. This may look like a horrible parameter question, but Cambridge only expects one thought, right? So if you have parallel lines, so parallel lines, it means equal gradients, right? And if you have perpendicular lines, which should be like this, then the product of the two gradients must be equal to -1, right? Once you recognize this relationship, the algebra almost writes itself. Okay, so top students don't know more mathematics than their peers. They simply identify the relationship before reaching for a formula, and that's the habit Cambridge is usually rewarding. Okay, so let me make 2 points. Let's say A, and let's say this is B. If I say, suppose I tell you that PA is equal to PB. Now, you have to find the point P, which is equidistant from A and B. Now, first thing that must occur to you and what your brain must tell you is that it should be the midpoint of A and B, right? So that's one answer, because P cannot be a single point if it's equidistant from A and B. It is a locus of points, right? Why? Because see, P could be here, or P could be right above it perpendicularly, such that this AB, sorry, this is a crooked line. I intended to make a straight line like this, such that this PA is equal to PB, right? And it makes an isosceles triangle. And then another point here, and then another point, another point, another point. So P is a locus of points such that P forms a perpendicular bisector of AB. So all these points on this green line are equidistant from A and B, and this green line L1 is the perpendicular bisector of A and B, right? Now, if you just blurted out that P had to be the midpoint of A and B, then that's wrong. You cannot apply the distance formula here. That's exactly what most students will do, and that's why many of them make coordinate geometry much harder than it needs to be. Okay, now, so you had to think about this physically, right? Imagine standing somewhere that is exactly the same distance from A and B. So it could be here as well. You see the distance equal from here to here and from here to here, right? It needed not to be right in the middle of these two, right, on a straight line. It could be here, it could be here as well, it could be here as well, because if you're standing here, you can see that this destination B and this destination A are both equidistant from you, right? The distance is equal. You could either go to A or to B. If the terrain and everything else is the same, and you don't have any preference between A and B, then you could choose between either of the two destinations, because these paths have the same distance, right? So therefore there are infinitely many such points, right, on this green line. So now every single one of these points is equally far from A and B, and they are making isosceles triangles, right? So whenever Cambridge tells you that PA is equal to PB, right, PB is equal to PA, right, you don't immediately think that you have to apply the distance formula or the midpoint formula. Rather, you think that it ought to be a perpendicular bisector, and that's the geometry hidden underneath the algebra. Okay, now let's say I tell you that there are 3 points, P, which is 1 comma 1, Q, that is 1 comma 8, and R, that is 6 comma 6. Now these are the given points. Now I want you to find the equation of a perpendicular bisector of PQ. That's very easy. So perpendicular bisector of PQ is what? So horizontally, okay, so P and Q lie on a vertical line, because this is 1, so this is P and this is Q. This is at 1 and this is at y coordinate 8. So the perpendicular bisector is going to go right in the middle of it from 9 by 2. So y equals to 9 by 2. That's very easy, right? So I mean, that's fairly easy if I had to find the equation of the perpendicular bisector of P and Q. Instead, if Q was, let's say, slightly different, if it was 3 comma 8, right? Now this 3 comma 8, Q is going to be somewhere here. And now if you had to find the equation of the perpendicular bisector of P and Q, then you would first find the midpoint of P and Q, which will be 2 comma 9 upon 2, right? Vertical average and the horizontal average, and then you have to take the negative reciprocal of the PQ gradient, which is going to be 8 minus 1, which is 7 upon 3 minus 1, that is 2. So if it is 7 upon 2, if this gradient of PQ is 7 upon 2, then the gradient of the perpendicular bisector is going to be negative 2 upon 7. So now I'm going to use the point gradient formula. So this is the gradient. So y minus y1 is going to be 9 upon 2 is equal to mx minus x1. X1 is going to be 2, which it is passing through. So it is passing through this point, 2 comma 9 upon 2. So this is the point gradient formula. So this is going to be y equals to negative 2 upon 7x plus 4 upon 7 plus 9 upon 2, whatever this constant is going to be. And this is where this perpendicular bisector is going to cross the x-axis, the y-axis from, right? So this is the equation that you will find now. So now let's say I give you another geometry, right? Let's say I tell you that there are 3 points, P is 1 1, Q is 3 comma 7, and R is, I don't know, let's say 6 comma 6. Now, so these are 3 points, and roughly they should be somewhere here, here, and here, right? If I ask you to find me a point which is equidistant from both these three, from all 3 points P, Q, and R, right? Now, so first of all, if it is a point which is equidistant from P and Q, so you must find out, so if this is P, this is Q, this is R, and if this one particular point is equidistant from P and Q, then you must find the perpendicular bisector of that, right? So this is the perpendicular bisector of P and Q, right? I am putting it in sub, PQ and sub. Now, that particular point is also equidistant from P and R, right? So if it is equidistant from P and R, then we must also find the perpendicular bisector of that. And so I can already see that this and it that particular point must also be equidistant from this. So we find that particular perpendicular bisector as well for Q and R, and then we are going to find this point. And how do you find this point? So you have to find the equation of the perpendicular bisector of PQ and perpendicular bisector of either QR or of PR. So out of the three perpendicular bisectors, find any two of them and then solve it algebraically in simultaneous equation in order to find this equidistant point. Let's call it A. Okay, and this is how you are going to find it. We are going to do and surprisingly, this equidistant point is where you have incidentally discovered how the center of a circle is also formed, right? But that's not the agenda for this lecture. We are going to cover that in our next upcoming lecture on Friday. So this is coordinate geometry. You have seen and coordinate geometry is not just midpoints, it's not just gradients, it's not just equations of line. Today you have seen that Cambridge rarely tests a formula. It tests whether you can recognize a relationship. Let's say that you're given rhombus, right? If you're given rhombus, then you must know that if this is A, this is B, this is C, and this is D, then the relationships that you can form is that the distance of AB, and you have done the formulas for distance, must be equal to the distance of CD and must be equal to the distance of AC because it's a rhombus, and must be equal to the distance of BD. So that's one relationship. Now, whichever coordinates are given to you already, you can use those in order to minimize the number of unknowns in your equations, right? Now, it must also show you that AC is parallel to BC, which BD, which means that their gradients are going to be equal, and AB is going to be parallel to CD. So this is going to give you another. So you can find quite a few equations through if you are given a rhombus and the coordinates of a rhombus. Now, similarly, if you are given a parallelogram, and this is A, this is B, this is C, this is D, then the distance of AB is going to be equal to the distance of DC, right? That's one thing. And distance of AD is going to be equal to the distance of BC. So these are two equations. And another two equations would be that AB, the gradient of AB is same as the gradient of DC, right? And the gradient of AD is going to be equal to the gradient of BC. So you can form four equations for a parallelogram as well, right? Now, you have seen that Cambridge rarely tests a formula. And when 3 points are collinear, you have to think for equal gradients, right? So if 3 points line on a same line, which means and they call it a collinear, they call those points collinear, then you have to think about equal gradients between AB, AC and BC, right? Now, when 2 points are equidistant, then you have to think about perpendicular bisectors. So if this is A, this is B, this is A, this is B, and if there is a point which is equidistant from A and B, then the point must lie on the perpendicular bisector of A and B, right? Now, when a midpoint is given, you have to think of averages before you think of algebra, right? Because if this is the midpoint of this and it is given, let's say it is given as 2,7, and this is given as, I don't know, 5,11, and this is given as A, B, then you must know that the average of A and 5 is producing 2, and the average of B and 11 is producing 7. Or you can even apply the formula for midpoint and do it, but it's just the same. Now, when a parameter appears, stop calculating and ask what must be true, right? You have to do that. That's the difference between solving questions and thinking like an examiner. That's the difference, and the latter is where you are going to score full marks. Okay, if you have followed this series from functions through quadratics and now coordinate geometry, you have built a toolkit that Cambridge expects every student, AS student, to see. But we are not done, because in the next chapter on Thursday, not Friday, something interesting happens. All of these ideas, they come together: the quadratics, the functions, the coordinate geometry, the midpoint, the perpendicular bisectors, everything. So gradients, perpendicular lines, the bisectors, even completing the square form, they all appear inside one topic, and that's going to be circles. You'll finally understand why the radius Okay, this is not going to form the radius automatically. I must use a pen. Why the... Okay, so why the radius of a circle... Wait a second, give me a moment. Yeah, why the radius of a circle is always perpendicular to the tangent. The tangent is going to be right here. As you can see that this always connects with the tangent at 90 degrees. How the equation of a circle hides its center and radius. So x square plus 2x plus y square minus 4y is equal to, I don't know, -1. So it hides a radius as well as the as well as the center of it, right? And we will be doing how to find those, right? And why coordinate geometry was never a separate chapter. It was preparation for what's coming next, and which is circles, right? Now, if you found this lecture useful, subscribe to the channel, share it with a friend who's preparing for AS mathematics, either resetting in October, November, or appearing or has moved from O levels to A levels and will be setting in May, June 27. If you found any idea that was not clear, leave a comment in the comment section, right? And if you want structured guidance through the entire 9709 syllabus with past papers, assignments, and live classes, you can join our group at Easy Talim. On Instagram, you can DM us, and our handle goes like Easy Talim, EASYTALEEM. You can also, for counseling, you can reach out to me free of cost on my WhatsApp, which is +92 329 3028 485. Okay, so I'll see you guys in the next lecture where we begin circles. So see you then.